They say nothing can travel faster than light. But what if that wasn't true? The room was silent. Not the kind of silence you hear at night, but a silence so complete it almost had weight. You could feel it pressing on your ears. Deep in the void between stars, something was moving. It's faster than anything ever had. It's faster than light. And yet, it wasn't breaking any rules, or so it seemed. You see, for over 100 years, we've believed light is the universal speed, limit immutable, sacred, eternal. But lately, tiny cracks are forming in that belief. Strange anomalies. Flickers of something beyond, and the more we look, the more we realize we might not know what light really is. Chapter 1. The lie we live inside in every school across the world. Children are told a story. It's elegant, beautiful, and wrong. They're told the universe has a speed, limit 299,792,458 meters per second, that nothing, not even time itself, can outrun this. That light is the fastest thing that can ever be. It's comforting, fixed, orderly. But the universe doesn't care about what comforts us. In fact, it seems to enjoy unsettling us. Chapter 2. The Flash That Shouldn't Exist, 2019. Deep inside a lab buried beneath Switzerland, researchers ran a routine test of neutrino speed. These ghost-like particles, nearly massless, should follow the rules. But one stream of them didn't. They arrived too early, not by a margin of error. Not by accident. By 60 nanoseconds, too small to notice in daily life. But in physics, it's the equivalent of watching someone walk through a wall. Most scientists dismissed it. Some didn't. Because if neutrinos could do it, then maybe light isn't what we think it is. Chapter 3. What is light, really? Let's stop pretending we understand light. We know it behaves like a wave, but also like a particle. We know it bends around stars, but also shoots straight through the vacuum. We know it illuminates everything, but we don't really know why. It moves the way it does. Here's a disturbing thought. What if light is not moving at all? What if we are moving through a medium we don't understand? What if light is just the trail left behind by something faster, deeper, stranger? Chapter 4. When Einstein had doubts in 1905, Einstein laid down his theory of special relativity. It gave light its crown. Nothing can move faster. Time dilates, mass increases. Energy becomes infinite. But what most people don't know is that years later, Einstein questioned this. He didn't trust quantum entanglement. He hated the idea of spooky action at a distance. It violated his precious speed limit, but the math, .. kept working. And the results? It kept proving him wrong. In one private letter, Einstein wrote, "Greater than perhaps there are deeper symmetries we have not yet touched." What did he mean? Was he hinting at a universe that doesn't play by light's rules? Chapter 5. Forbidden zones of physics. There are regions of space where time breaks down near black holes. Inside wormholes, at the edge of what we call reality, in these places, light doesn't behave. It bends, it stalls, it disappears. And something else, something we don't have a name for, seems to slip through. No camera has captured it. No scientist can explain it. But astronauts in deep space, observers have described it the same way. A shadow that moves before light arrives. What kind of entity casts a shadow in front of the light? Chapter 6. Whispers from the tachyon realm. Theoretical. Particles called tachyons are said to travel faster than light. They aren't real, or at least they're not supposed to be. But buried in 1980 Soviet research are field equations that predicted tachyon fields. And some even matched satellite interference patterns that remain unexplained. Could there be something traveling faster than light? Or more terrifying, could everything we know be moving within a faster medium we cannot see? Narrator soft, ominous. If light is the speed limit of the universe, then who or what built the sign? It's Chapter 7. The hallway that bends backward picture. You walk down a hallway. At the end is a mirror. You shine a flashlight. The beam travels, reflects, and returns. Now imagine that halfway through the hallway. Time folds not like bending a paper, but like the hallway itself loops inward. the flashlight beam disappears, and returns before you shine it. This isn't fiction. It's based on a mathematical construct called a closed time-like curve. A loop in space-time where cause and effect blur. It only exists in theoretical physics. But if such curves are possible in certain conditions, say, near a rotating black hole, then it implies something profound. Greater than there are pathways where light can loop. And if light can loop, maybe it's not traveling in a straight line at all. Maybe. We just see it that way. Chapter 8. Entanglement. A faster whispering 2015. Scientists performed a loophole-free test of quantum entanglement. Two particles, separated by 1.3 kilometers, responded to changes in each other instantly. Not very fast. Instantly, no information should travel faster than light. Yet here it was. Verified, peer-reviewed, repeated. So the question emerged. Greater than is something faster than light communicating behind the scenes? If so, that something doesn't carry energy or mass, doesn't obey relativity. Some call it nonlocality. Some call it superdeterminism. But what if, what if, it's a signal moving on a deeper layer of reality? One we can't perceive, but that physics occasionally exposes, like a glitch in the matrix. Chapter 9. The illusion of movement Einstein. This relativity tells us something counterintuitive. The speed of light is constant to all observers. If you move toward a light source, it still approaches you at the same speed. If you move away, same deal. No other object behaves like this, which raises a deeply unsettling idea. Greater than light isn't moving at all. What if our experience of light? Traveling is our movement through a deeper fixed dimension, one where time and space are emergent illusions. This is more than philosophy. In loop quantum gravity and emergent space-time theories, light is not a particle in space. It's a ripple of space. And if that's true, then the idea of speed of anything moving may be just the way our minds interpret geometry. Chapter 10. The speed of thought in some rare moments of altered consciousness, deep meditation. Near-death experiences, extreme trauma. Humans report an unusual sensation, the world slowing down, and yet their thoughts speeding up. Could the human brain, in rare states, brush against layers of time deeper than we usually touch? Neuroscientists scoff. But one study at Johns Hopkins University, using hydrosilocybin, revealed patterns of brain activity that mirrored quantum coherence. The same principle that governs subatomic mathematical entanglement. This doesn't mean thoughts break the speed of light, but it raises a poetic possibility. Greater than, perhaps awareness, the thing that watches light, exists beyond speed. And maybe that's why we can even ask these questions at all. Chapter 11. Hidden Symmetries. Back in 1967, physicist Eugene Wigner wrote about the unreasonable effectiveness of mathematics in the natural sciences. What he meant was this. Why does math, pure abstract logic, describe the real universe so perfectly? Why should a human-made symbol on paper match what happens in a galaxy? Because math is a shadow of a deeper truth, one hidden behind the speed of light, one we sense, but cannot see. Greater than, we think we see everything, but light is just a messenger. What if there are messages we haven't learned to read? Chapter 12. Faster than fast. Let's stop for a moment. What would it actually mean for something to move faster than light? Would it become invisible? Would it go back in time? Would it destroy causality? Maybe, but maybe not. In 2007, a controversial paper proposed that faster-than-light particles wouldn't break causality if they existed in higher dimensions. To us, they'd seem to move backwards, or vanish. But in their own dimension there, just going about their business. So then comes the twist. What if light is one of those particles? We only perceive its lower dimensional shadow. Just like a 3D object casts a 2D shadow on a wall. Perhaps light is a projection of something moving freely in higher space. And that projection moving through our slice of reality is capped at 299,792,458 meters per second. But the thing casting it? Greater than light may not be the fastest thing in the universe, Just the fastest thing we can see. Chapter 13. The silence beneath the signal radio. Telescopes listen to the cosmos like ears tuned to a symphony no one else hears. One night in 2022, a deep space array in Australia recorded a frequency spike. It wasn't a standard FRB fast radio burst, nor a pulsar. Echo it was. Quieter. A dip in frequency followed by a rebound, lasting only a fraction of a millisecond. But buried in that pattern was something researchers couldn't explain, a mirrored waveform, as if the signal was reflecting off something invisible. There was no known body or gas cloud to cause this. The theory? A reverse front faster than the original lighted disturbance that moved faster than the light that followed it, warping the path of photons behind. One scientist whispered off record, "It's like something cleared the way before the light arrived, and then left no trace." Chapter 14. Echoes without sources in Antarctica. During cosmic ray detection experiments, sensors picked up a phenomenon that shouldn't exist. An upward-moving cosmic ray. That's right. Instead of coming from space and hitting Earth, it seemed to come from within Earth and shoot outward, as if launched from below. Some claimed faulty readings, others weren't so sure, because the energy was too high, the angle too precise, timing too perfect. So what did it mean? One radical hypothesis proposed by a team in Italy was that we're seeing reflected signals of faster-than-light particles moving through dimensions we don't normally detect, bouncing off some unknown structure beneath our feet and re-emerging in distorted form. Greater than it's not that they're defying physics, it's that they're obeying deeper physics. Chapter 15. Dimensional. Rift theory, a proposal in string theory, suggests our universe is a three-dimensional brain floating in a higher dimensional space. Picture a slice of paper floating in a room. You are the paper. You live on it, move on it, think on it. But above and below that paper, a vast unseen world. If light is bound to our brain, then the speed of light might be a property of our membrane, not a universal law. Other brains could have different speeds or none at all. Worse, two brains could collide, and in that collision, particles would behave chaotically. Light might appear to vanish, slow down, or even reverse, not because of a flaw in light, but because of dimensional drift. So here's the disturbing question. Greater than, is the speed of light stable? Or is it just stable right now? Chapter 16. Photons that cheating 2000. At Princeton University, a light pulse was passed through cesium gas. What happened shocked the scientific world. The pulse appeared to exit the gas before it even fully entered it. Measured speed, 300 times faster than light. Did this violate Einstein? Not quite. The pulse was distorted, Dre-shaped, in a way that suggested it exited faster. But technically, no information was transmitted faster than light still. The implications were staggering, because it showed that under the right conditions, photons could be manipulated to behave as if faster-than-light travel were possible. And if that illusion can exist, maybe the boundary is thinner than we thought. Chapter 17. Time isn't what you think here. Psst, a theory whispered in the halls of quantum cosmology. Greater than time isn't a line, it's a cloud. We treat time as moving forward tick by tick, second by second. But in quantum mechanics, time is not always linear. Particles can interfere with their own past versions. Future probabilities can influence present behavior. If time is a fog, then light or precious timekeeper might just be a guide through the mist, not a universal law. In that fog, there might be shortcuts. What we call faster than light might just be the absence of delay, no road, just arrival. Chapter 18. The dark conductor, dark matter. It's everywhere. It makes up 85% of the universe. We can't see it. We can't touch it. We know it's there. Pulling, guiding, shaping galaxies. But what if dark matter doesn't just affect gravity? What if it guides light? Imagine dark matter as a hidden conductor, redirecting the paths of photons like an unseen lens. Sometimes resisting them. Sometimes carrying them faster than they were meant to go. Could dark matter be a medium? A carrier? If so, then light doesn't move. Freely it moves along a network we can't perceive. And in that network, speeds might vary. Constants might crack. Greater than light is not what it seems. It obeys because it must. But what does it obey? Chapter 19. Forbidden geometry. All space is created equal. In non-Euclidean geometries, space can curve, twist, loop, fold in certain topological models. Light can reach a destination without traveling through space. Takes a shortcut. Through warped geometry, imagine 2 points on a sheet of paper. Now fold the paper until those 2 points touch. That's what certain quantum geometries suggest about spatial. So when we measure light speed, we may not be measuring how fast something moves. We may be measuring how bent the path was, and in that bending lurks the illusion of limitation. Chapter 20. A universe without limits, what would it really mean if something could move faster than light? Our equations would collapse. Causality would break. Paradoxes would flood in, or ... Perhaps none of that. Because maybe our universe is already full of faster-than-light phenomena. Maybe we just can't detect them because our senses are tools. Even our thoughts are limited by the same light we worship, and only when we let go of that limit. Can we see the universe not as it is, ... but as it has always been? Greater than? They told us light was the limit, but the universe never agreed. Asterisk, they told us nothing could move faster than light. But we kept looking anyway, because deep inside the minds of the most curious scientists were questions too dangerous to ask out loud. What if the speed of light isn't a law, but just a reflection of our limits? What if we've built our understanding of the universe on a rule that was never really true? If something can move faster than light, then it can move through time. It could arrive before it ever left, could know things before they happen. And somewhere, deep in the folds of space-time, such a thing might already exist. In the center of a neutron star, where density reaches impossible levels, gravity doesn't. Just bend light, it tears at it. Some physicists believe that in these conditions, space itself breaks. And when it breaks, light's obedience begins to falter. The equations start to twist. The geometry collapses. Something leaks through. Something that doesn't slow down. Something that doesn't care about our speed limits. Every time we find a boundary in physics, we call it a law. But the universe has a long history of breaking its own rules. First, we believed Earth was the center, then the sun, then the galaxy. Each time, we were forced to admit we were wrong. So why should the speed of light be any different? The ancient Greeks believed light came from our eyes, that it traveled outward, touching objects. For centuries, this absurd idea persisted. It took generations to discover that light doesn't come from us, it comes to us, and even then we barely understood what it was. Today we still don't. Light is not a substance. It's not a wave in water. It's not a thing you can hold. It's a behavior, a disturbance in a field, a probability. We don't know what moves at the speed of light. We just see the effects. Imagine you're standing on a frozen lake. You drop a stone. The ripples move outward. But you don't see the stone. You only see the circles it leaves. That's light. We see the circles. But we've never truly seen the stone. And what if the stone isn't even in our universe? In quantum field theory, particles aren't objects. They're excitations, blips of activity in invisible fields that stretch across space. The photon is a ripple in the electromagnetic field. But what creates the ripple? Where is the hand that flicks the surface? Could that hand belong to a dimension beyond ours? A realm where information doesn't travel, it simply appears? If that's true, then our entire understanding of speed collapses. Because speed requires distance. Speed requires time. If neither distance nor time are fundamental, then what is light even measuring? Our instruments are flawed. They're built to detect what we already believe. We shine lasers through vacuums and watch clocks tick, and we say, yes, there it is. The constant. But every measurement assumes the same foundation. What if the truth lies outside that system? In ancient myth, Hermes was the messenger god, one who could move freely between the mortal world and the divine. In modern physics, light is our Hermes. It brings information from the stars. It defines our causality. But even Hermes had limits. There are whispers in the equations, strange cancellations, unexplained coincidences, constants that match in ways they shouldn't. The fine structure constant, the speed of light, Planck's constant. They fit together too neatly, as if designed. Some say this is the mark of a creator, so others say it's the fingerprint of a simulation. But what if it's neither? What if it's the result of something moving through our universe from another layer compressing? Information, reshaping rules, making light obey, ... for now. When black holes collide, they send ripples through space-time. Gravitational waves, we've measured them, felt them, but those waves don't obey the speed of light. Not perfectly. Sometimes they seem to travel differently, distorted, delayed, advanced. It's as if space-time itself carries memories of motion. And in those memories, the idea of speed becomes slippery. There are respected physicists who believe space-time isn't fundamental, that it's emergent, that our universe is made of information, that what we call light is simply the transmission of code through a cosmic processor. They told us nothing could move faster than light. We kept looking anyway, because deep inside the minds of the most curious scientists were questions too dangerous to ask out loud. What if the speed of light isn't a law, but just a reflection of our limits? What if we've built our understanding of the universe on a rule that was never really true? If something can move faster than light, then it can move through time. It could arrive before it ever left, could know things before they happen. And somewhere deep in the folds of space-time, such a thing might already exist. In the center of a neutron star, where density reaches impossible levels, gravity doesn't just bend light, it tears at it. Some physicists believe that in these conditions, space itself breaks. And when it breaks, light's obedience begins to falter. The equations start to twist. The geometry collapses. Something leaks through. Something that doesn't slow down. Something that doesn't care about our speed limits. Every time we find a boundary in physics, we call it a law. But the universe has a long history of breaking its own rules. First, we believed Earth was the center, then the sun, then the galaxy. Each time, we were forced to admit we were wrong. So why should the speed of light be any different? The ancient Greeks believed light came from our eyes, that it traveled outward, touching objects. For centuries, this absurd idea persisted. It took generations to discover that light doesn't come from us. It comes to us. And even then, we barely understood what it was. Today, we still don't. Light is not a substance. It's not a wave in water. It's not a thing you can hold. It's a behavior, a disturbance in a field, a probability. You don't know what moves at the speed of light. You just see the effects. Imagine you're standing on a frozen lake. You drop a stone. The ripples move outward. But you don't see the stone. You only see the circles it leaves. That's light. We see the circles. But we've never truly seen the stone. And what if the stone isn't even in our universe? In quantum field theory, particles aren't objects. They're excitations, blips of activity in invisible fields that stretch across space. The photon is a ripple in the electromagnetic field. But what creates the ripple? Where is the hand that flicks the surface? Could that hand belong to a dimension beyond ours? A realm where information doesn't travel, it simply appears? If that's true, then our entire understanding of speed collapses. Because speed requires distance. Speed requires time. But if neither distance nor time are fundamental, then what is light even measuring? Our instruments are flawed. They're built to detect what we already believe. We shine lasers through vacuums and watch clocks tick, and we say, yes, there it is, the constant. But every measurement assumes the same foundation. What if the truth lies outside that system? In ancient myth, Hermes was the messenger god, the one who could move freely between the mortal world and the divine. In modern physics, light is our Hermes. It brings information from the stars, defines our causality. But But even Hermes had limits. There are whispers in the equations, strange cancellations, unexplained coincidences, constants that match in ways they shouldn't. The fine structure constant. The speed of light, Planck's constant. They fit together too neatly, as if designed. Some say this is the mark of a creator. Others say it's the fingerprint of a simulation. But what if it's neither? If it's the result of something moving through our universe from another layer, compressing information, reshaping rules, making light obey? For now, when black holes collide, they send ripples through space-time. Gravitational waves. We've measured them, felt them. But those waves don't obey the speed of light, not perfectly. Sometimes they seem to travel differently, distorted, delayed, advanced. It's as if space-time itself carries memories of motion. And in those memories, the idea of speed becomes slippery. There are people-respected physicists who believe space-time isn't fundamental, that it's emergent, that our universe is made of information, that what we call light is simply the transmission of code through a cosmic processor. And in a processor, data doesn't travel, jumps. From state to state, no distance, no speed, just change. Universe is digital, then the speed of light is not a limit. It's a frame rate, and frame rates can be exceeded. We stare at the stars and measure redshift. We say, that galaxy is moving away from us. But that's not what we're seeing. We're seeing stretched light, changed wavelengths. And we interpret that change as motion. But what if something else is happening? What if the universe isn't expanding? What if light is slowing down? In a bold hypothesis, some physicists have proposed that the speed of light was faster in the early universe, that it decays slowly, predictably. If true, it would explain a lot. The horizon problem, the uniformity of cosmic background radiation, even inflation. But it would also mean that light has no fixed speed, that what we call a constant is just a phase. And if that phase ends, what comes next? In certain crystals, light can be slowed to a crawl. Not metaphorically, literally. Experiments have shown that a laser beam passed through a cloud of chilled sodium atoms can be slowed to 17 meters per second. That's about the speed of a bicycle. And when it exits, it returns to normal. But that means speed is contextual. It means light isn't bound to one number. It obeys the medium. And maybe space itself is a medium. Maybe it has density, viscosity, resistance. And maybe that resistance can change. What would happen if space became thinner, less dense? Could light go faster? What if there are regions in the universe where space is so empty, so pure, that light doesn't slow down, it speeds up? And what if something else already lives there? All our laws are based on observation. But we only observe from one place, one speed, one gravity, one slice of the cosmic pie. There are 1,080 particles in the observable universe, but outside that observable limit, infinite possibilities. We assume the same laws apply. They don't have to. They just do. Here we've built a physics that works in our neighborhood, but the universe isn't a neighborhood. It's a wilderness. And in that wilderness, light may not be king. We worship it because it lets us see. That defines our past, our present, our distance, our destiny. But maybe that's the trap. Maybe light is the veil, not the truth, but the mask that hides it. And maybe, just maybe, if we find a way to look beyond it, we'll see a universe not ruled by speed, but by something else entirely. Something that doesn't travel. Something that arrives. Asterisk, there's a theory, rarely spoken out loud, that light is not a constant at all, but a side effect. That what we call light is merely a surface ripple of a deeper, faster, more fundamental motion we can't yet detect. If that's true, then the speed of light isn't the limit. It's just the limit of how fast we can be noticed. Think of a shadow on a wall. It appears to move. It can even seem faster than the object that casts it. But it isn't moving, it's just a projection, a consequence of deeper movement elsewhere. What if light is like that? What if what we call speed is just the measurable tip of something vast and immeasurable below? In some advanced models of the universe, like string theory or loop quantum gravity, space itself is not continuous, but made of tiny, indivisible units, like pixels on a screen. And just as animation doesn't require motion, between every pixel only, a change in state. Maybe the universe doesn't require light to travel. Maybe it just updates, frame by frame, Planck time by Planck time. And in those moments between updates, infinitesimally short as they may be, maybe information moves freely, without speed, without resistance, instantly, not because it's breaking the rules, but because it exists between them. To us, these transitions would look miraculous, like particles appearing where they shouldn't, entanglements that defy space, accelerations that surpass any possible energy source. We'd call them violations, but maybe they're not violations at all. Maybe they're glimpses of the real engine behind the universe, an engine not bound by speed or mass or light. This brings us to one of the strangest ideas in modern physics, retrocausality. In this concept, events in the future can influence the present because time is not a river, but a field, a four-dimensional block where past, present, and future all coexist. Light moves through this block at a fixed rate, defining our experience of time. But what if something else moves differently? What if information can flow backward through the block? Some interpretations of quantum mechanics, like the transactional interpretation, suggest just that particles communicate both forward and backward in time before settling on an outcome, that every interaction is a handshake across time to us. It looks like randomness, probability, quantum, indeterminacy, but maybe it's not random at all. Maybe the photon isn't deciding which slit to pass through. Maybe the future observer is. Maybe the act of seeing now or later itches back and shapes the path. And if that's the case, what else might we be influencing without knowing it? Could we, by observing light, change the structure of space itself? Could our measurements, tools, our curiosity be rewriting the laws as we go? The more we look, the stranger light becomes. In 2022, scientists studying extreme energy cosmic rays detected something odd. Particles arriving with energies higher than the GZK limit, the maximum predicted by standard models to reach us. These particles would have had to break the speed of light in their local medium. They shouldn't exist, but they do. Are they mistakes? Equipment error? Statistical flukes? And that deeper world might be right here, hidden in the very gaps between our moments, in the spaces our instruments can't reach, in the whispers between particles when no one's watching, because even silence has structure. Physicists once believed the vacuum was empty, a void, a nothingness. But now we know the vacuum is a storm, a roiling, energetic sea of virtual particles popping in and out of existence, borrowing energy from nowhere, disappearing before they can be caught. This vacuum energy is so powerful that if we could tap into even a fraction of it, it could boil the oceans in a heartbeat. But we can't. Not yet, because it flickers in a realm beyond light, beyond measurement, beyond time. And here's the most terrifying thought. What if that's where the real computation of the universe takes place? Not in atoms or molecules or even photons, but in the invisible transitions between them. In the space where nothing is, and yet everything comes from quantum tunneling. And another mystery. Particles appear on the other side of barriers without crossing them. How? We don't know. We just know that it happens. To do this, particles would have to take a path forbidden by classical physics. Something. It's faster than any signal could carry. But maybe that's the wrong way to think about it. Maybe the particle doesn't move faster than light. Maybe it doesn't move at all. Maybe it just stops existing in one place and starts existing in another, without time, without distance, without travel. To us, that looks like magic. But to the universe, it might be normal. And if particles can do it, what else can? Are there thoughts that don't originate in brains? Ideas that arrive not by reasoning but by resonance? If space itself has a hidden geometry, a kind of metaphysical circuitry, then maybe what we call insight is just a local activation of a deeper network. Something pulses. Something connects, and suddenly light isn't carrying information. It's responding to it, reacting to instructions written outside our dimension. A code, one we can't read yet, but sometimes, we feel it. We see its echoes in the fractal patterns of nature, in the symmetry of snowflakes, in the spin of galaxies, in the uncanny efficiency of DNA. We hear it in music that moves us beyond explanation. We dream it in visions we don't understand, and occasionally we stumble across it in the lab where something behaves not as it should, but as if it's being watched by something that already knows the outcome. The photon in the double slit. Experiment doesn't just change its behavior when we look, it changes based on how we might look. It behaves differently, even if the measurement device is turned off so long as the possibility of observation exists. This suggests that reality isn't shaped by action, but by potential. That possibility itself has power, and that, perhaps, is the true speed of the universe, not meters per second, but options per moment. The unfolding of paths not by energy, but by awareness. This would mean that the cosmos isn't a machine, grinding forward on rails of cause and effect. It's a canvas where every brushstroke alters not just the image, but the rules of painting and light. It's just one color, one voice in a larger song. So what happens when we stop listening only to that voice? What happens when we start hearing the silence between the notes? When we stop measuring speed and start feeling direction? Maybe then we'll realize we were never chasing light. We were remembering it. Asterisk, but remembering implies something forgotten, something ancient, buried deep, not in the earth or in the stars, but in us. We treat light as discovery, as the first illumination, the primal force that revealed the world. But what if light didn't reveal the universe? What if it concealed it? What if the constancy of light is a masked, stable, predictable, reliable knot? Because that's all there is. But because it's the safest thing our minds can handle. In dreams, reality bends, time fractures, places change without motion. Yet, it all feels familiar, possible, intuitive. Why? Because perhaps part of us still remembers the deeper rules, the ones not based on speed or distance, but on meaning, on context. And in that framework, light doesn't travel, it emerges. It doesn't illuminate. It disguises. It distracts. Because what lies underneath, what moves without moving, what exists beyond time is too vast to face directly. The ancient mystics spoke of this. The idea that there is a veil over reality. We see only shadows on the wall. That behind the light is a darkness, not of absence, but of total presence. A place where everything is connected, not by path, but by pattern. Modern physics calls this nonlocal. In quantum entanglement, two particles remain linked no matter how far apart they are. Measure one, and the other responds instantly. If they're light years away, it doesn't make sense in our spacetime. It shouldn't be possible, and yet it is, because the connection doesn't travel. It just is. It's not a signal. It's a shared identity, and if identity can stretch across the cosmos without moving, then so can information. So can structure. So can intention. Which means that maybe we don't live in a universe defined by distance, but by resonance and light. As fast as it is just the local echo of that resonance, like thunder after lightning. So what does it mean to go faster than light? Maybe it means skipping the thunder. Maybe it means listening directly to the flash, or even better, becoming it. Because at the very heart of physics, beyond all the equations and experiments, lies one unanswered question. What is light? A particle? A wave? A vibration in a field? Or is it ... a boundary? It's the edge of what we're allowed to know, and what lies beyond that edge? Possibility, paradox, or maybe ... truth? Asterisk, truth isn't always what we can prove. Sometimes it's what persists quietly beneath the noise. The subtle symmetry that survives even when theories crumble. The echo we keep hearing, no matter how far we run from the source. And in the study of light, that echo is everywhere. In the photoelectric effect, where Einstein showed that light could knock electrons from metal but only if its frequency was high enough. It's not its brightness, its rhythm. That was the first crack in the idea that energy moves smoothly, and it wasn't just a scientific shift. It was a spiritual one, because it implied that light doesn't flow like water, it hits like music, in beats, in packets. Discrete quanta, like a message. But who or what's sending it? That's not something science is supposed to ask. It's not falsifiable, not measurable. And yet we ask anyway. Because the deeper we go, the more we find design without designer, pattern without planner, rules that seem chosen, not random. The fine structure, constant, and number that governs how light and matter interact is one of the most mysterious constants in physics. It's about 1/137,035,999. Why? We don't know. It shows up everywhere, from atomic spectra to black holes to the expansion of the universe. It has no units. It's dimensionless. Just a pure number. Some have speculated that if it were even slightly different, the universe, as we know, it couldn't exist. Why this number? Why not 1/138th or 1/136th? Is it coincidence or is it code? We talk about the laws of nature as if they're fixed, eternal. But what if they're not? What if they're the visible part of a deeper language, one that adapts to its speaker? What if consciousness isn't an accident within the laws, ... but the reason they exist at all? Because here's the paradox. We study light using tools. Made of matter, we interpret its behavior through minds built from atoms. We define its speed using clocks that rely on its own motion. We are the observers, and yet we are also part of the system we observe. That means we can never see light purely, only as it reflects through. And maybe that's the final secret. That light is not the ultimate speed, not the boundary, but the mirror, showing us not how fast the universe moves, but how far we are willing to look